Hello everyone, I am working on a project named Automated Crop Yield Prediction for Telangana State. I am Lokesh from second year CSCB. As we all know that in India, 50 to 60% of the population is directly or indirectly involved in the farming. So, predicting the yield will be very useful for the farmers to manage their finance and farming. So, let us talk about the project statement. In this project, I am going to develop a cloud-based machine learning model that can predict crop yield based on the data provided by the user or the farmer. The data provided by the user or the farmer will be weather, weather patterns, soil fertility, irrigation level, soil nutrition, crop type or crop name, and many other parameters. It is going to have a user friendly interface so that the users can use it very simply, and this model will help the farmers to optimize their crop management and improve their harvests. So in this project we are going to use technologies such as Amazon Web Services, machine learning, SageMaker, and UI tools like React.js. We are going to use AWS for our cloud related part, machine learning, and SageMaker. SageMaker is the AWS service which is we are going to use this to train our model and test it, and React is for the user interface. So now let us talk about the phases of the project. The phases of the project are as follows: data collection, data pre-processing, data analysis and modeling, model training and evaluation, deployment and integration, and monitoring and maintenance. So let us talk about data collection. In data collection, we are going to collect data regarding various parameters and we are going to merge it. In data pre-processing, we are going to pre-process the data and make the data very useful so that the accuracy of the model will be increased. In data analysis and modeling, we are going to train the data with the various models, and we are going to select a model with will be giving higher accuracy. And in model training and evaluation, we are going to train the model and test with our data set, and we are going to evaluate it. In deployment and integration, we are going to deploy our web page in Amazon AWS, and we are going to monitor and maintain it using AWS. So now let us talk about the basic UI of our project. As you can see here, the user interface would be similar to this. The user will be provided three buttons: yield prediction, crop prediction, and data set. Let us say that the user clicked on the button yield prediction. When he clicks on that button, he will get an interface which will be asking him to fill these parameters such as rainfall, temperature, irrigation, and others. When he fills the values, then he can get the yield predicted by our model. And if he clicks the button, the crop prediction, then he need to similarly fill the values which he had provided previously in crop yield, and then he will get the crop which is suitable to grow in this condition and that location. And when the user clicks on the dataset button, then he'll again provide with another UA where he'll find two buttons by which he can view the database, or else he can download the dataset also. After downloading or while viewing the dataset will be similar to this, and he can use it as a reference to fill the parameters. Now let us talk about the add-ons. Before talking about add-ons, first we need to know what are add-ons. They are basic features added to a project or an app or a website to increase its functionality. So in our project, we are going to add some add-ons such as location API and weather API, by which the users need not to fill the location and the weather related parameters such as rainfall and temperature. It will be filled automatically using this API. And one more add-on is that we can add a feature of various language accessibility, since in India there are very less farmers who know English language. By adding this feature, our project will be very user friendly for our Indian farmers. And another feature would be automatic data updation. Like when a farmer enters the parameters, then these parameters will be automatically added to our data set, which will be further used, and it will be trained by the model, and it will be further used for prediction, which by which we can increase the accuracy of our model. And other thing is we can integrate with the government to reach as many as farmers we can. And the last one would be we can have a subscription based model by which when a user subscribe to our website, then he or she will be getting a machine by which he or she can test the soil instantly instead of going to lab and wait for 2 to 3 days for the results. So now let us talk about what I have learned during this project school. So at the beginning of the project school, during the first 3 weeks, I have learned about AWS cloud computing and the services provided by AWS. So let's see what are the services I have learned in AWS. One of the services is S3 bucket, EC2 instance, DynamoDB and Lambda function. So let me briefly explain about each of the services. So S3 bucket is a cloud-based object storage service provided by AWS that allows the users to store and retrieve data from anywhere on the web. EC2 instance. It is a service provided by AWS which provides a virtual server in the cloud that can be used to run applications and store data and host various websites. DynamoDB. It is a service provided by AWS. It is a fully managed NoSQL database service that can offer fast and predictable performance with seamless accessibility. Now let us talk about Lambda function. It is a serverless compute service provided by AWS that allows us to run code without providing or managing any servers. So now let us talk about data collection. It is one of the major tasks of our project. I have chosen these input parameters for 32 districts of Telangana. The input parameters are rainfall, minimum and maximum temperature, soil nutrients, irrigation value, yield and pH value of soil. I have collected the data from various sources as mentioned here. All sources are provided by the government. The next task is to merge the data. It is one of the difficult tasks in our project. While merging the data, I took district, season and year as a common attribute and I merged this data. As you can see here, it is the blueprint of our project. District, season, crop name, minimum and maximum temperature, rainfall, irrigation level, yield and soil nutrition. And soil nutrition contains sub-columns which are as I mentioned here, you can see here. Nitrogen, phosphorus, potassium, zinc, iron, copper and manganese are the sub-columns for the soil nutrients. Let us talk about data preprocessing. In data preprocessing, the steps involved are filling the null values, identifying the unwanted parameters and one-hot encoding. So to fill the null values, I have taken the mean of the particular district for a particular season and I use that mean to fill the null values. And the next step is identifying and removing the unwanted parameters. But doing it before, I did one-hot encoding because during one-hot encoding, we will get so many other columns and we can drop that columns while identifying and removing. We can drop that these columns while feature selection. So what is one-hot encoding? Basically, it changes the categorical value into numerical value. As you can see here, district, season and crop are the categorical values and we have changed it into numeric values such as zeros and 1. Now for feature selection, I used lasso regression. Lasso stands for least absolute shrinkage and selection operator. It is a statistical formula for regulation of data models and feature selection. As you can see here, it is a code for lasso regression. Here in X we selected the features or columns which we are going to drop and Y is the target feature. And when we print the features, we can see here the selected features are rainfall, minimum and maximum temperature, N value, K value, iron value, irrigation level. So now let us talk about what will be my future progress. Further, I am going to learn about the different models and how to apply this model on a data set. And I am going to learn about SageMaker and I am going to train models using SageMaker. And at the end, I am going to create a user-friendly UI using Mon. So Now let us talk about the problems I faced during working on this project. First of all, problems faced regarding data collection. While collecting the data, it was very difficult to find the sources for the parameters like soil nutrition. So I thought that I am going to remove the parameter and I am going to use soil type as a parameter. But it was a wrong step since the soil type varies from place to place, even from farm to farm, and it was difficult to collect that data. And if we collect the data would be not sufficient and the accuracy of the model would be fallen down. And another problem I faced was during data pre-processing. I had difficulty while finding the unwanted parameters. Like as I said before, I used lasso regression to find the selected features. As you can see here, I got rainfall, minimum and maximum temperature, N value, K value, iron value, irrigation as my selected features. But as we know that P value is one of the major parameter to find the yield. So we need to include that P value. So I am going to try another model such as PCA to check whether we can add P value as a selected feature or not. So I would like to conclude that in future I am going to work on this project and I am going to complete this project. This project would be very useful for our Indian farmers by which they can manage their finance and their farming, and it will be result in future that many of uh, young generation would choose farming as an opportunity. And at last, I would like to thank our mentors, Ashok Sharma sir and Kiran Mehman, for guiding me while doing this project. And Ashok Sharma sir was very helpful, like in cloud computing and other tech related topics. And ma'am was very helpful while collecting data and regarding the knowledge of domain. So thank you everyone.